Hello dear children, this is SB Raman and here I am going to take the video classes for 10th mathematics. As per the syllabus, there is the first chapter, arithmetic progression. In this chapter, we are going to discuss definition of an AP, then general form of an AP, then nth term of an AP, then sum of the nth term of an AP. So in that mainly, first we will discuss what is arithmetic progression. An arithmetic progression is a list of number. If a list of number have a definite rule, then that list of number can be said to be a progression, just a progression, because there are three types of progressions we can see: arithmetic progression, geometric progression, and then harmonic progression. Okay, like this, three types of progressions we can see. So in that mainly, what is arithmetic progression means? Here, an arithmetic progression is a list of number in which each term is obtained. Every term, each term is obtained by adding a fixed number to its preceding term. Okay, you can take whatever the number as a first term. So let us take a 3 as a first term. Okay, if you add a fixed number to this number, so now it is in a preceding term for the next number. Okay, if you add 3 to this, what we get 6. Okay, then what we have to add, don't have to change the adding number, so because that number should be fixed, the adding a fixed number. Okay, if you add 3 here, the next also you have to add 3. 6 plus 3, what we get? 9. 9 plus 3, what we get? 12. Okay, so like this, that an AP which is same, okay, with common difference t. Okay, the fixed number that we are going to add to the preceding term, that fixed number is said to be common difference. Like this, you can define arithmetic progression. An arithmetic progression is a list of number in which each term is obtained by adding a fixed number to the preceding term, except the first term. Then, so in this, the two types of arithmetic progressions we can see. One is finite arithmetic progression and another one is infinite arithmetic progressions. Okay, so finite, it means the number of terms in the progression are fixed. Okay, it may be 10 or it may be 5. So like that, the what example we see, that is 3, 6, 9, 10. Only 4 terms are there. If 4 terms are there, then it is finite arithmetic progression. Okay, if we write point means so on in front of the last term, then it means it is an infinite arithmetic progression. We'll see some examples for arithmetic progression. Some more examples here. 1, 3, 5, 7. The list of odd number is also an arithmetic progression. The list of odd number is also an arithmetic progression. See, which is the common difference here? 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7. Next number is 7 plus 2. Okay, like this, it come an infinite arithmetic progression. So here, the fixed number is 2. So that means the common difference. That common difference you can identify by subtracting the succeeding term with the preceding term. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, we get 2. Like this. The next list is the list of even numbers. Here also, the 2 plus 4. The 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So the common difference is 2. And the next number is 1, 5, 9, 13. See here, if you add 4 to 1, we get 5. 4 to 5, 9. 4 to 9, we get 30. Like this. So here, the common difference is here also the same or fixed, that is 4. Example for AP. So now we will see some examples. Some more examples. See here, 1, 2, 3, 4. Is this an AP? You have to tell. Yes, of course this is an AP, because the difference between succeeding and the preceding term. every succeeding and its preceding term is 1 here. Okay, that you can easily identify here. 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. Okay. While finding the common difference, you have to subtract from succeeding term to preceding term. Okay, if we get a same common difference, then it will be an AP. So like that. See the second one. 7 minus 3, 4. 11 minus 7, 4. 15 minus 11, 4. So like this. It is also an AP. The first one is 7, 15, 22, 30. So 15 minus 7, 8 we get. Then 22 minus 15, 7 we get. And 30 minus 22, again 8 we get. So here the common difference is not a constant. If a common difference is not constant, hence it is not an AP. Okay, or this sequence or this number series will not form an arithmetic progression. It is not an AP. Here we'll move to the next slide, that is general form of an AP. Okay, so in general we say that every number in the AP is said to be a term. Okay, so that is in general the first term A1, A2, A3, A4, so on up to AN. Nth term is a finite number. Okay, or it may be infinite. Here the first number is always considered as A, and the second number, how we get the second number? By adding a fixed number to the first number. Okay, so A plus D, that adding number is D. Here the common difference is considered as D in general. So A3 means how many times we have to add that add that D 2 times. So how many times we have to add that D 2 times, because we are finding the third term. That's why it becomes A plus 2D. Okay, so like that. Fourth term, A plus 4 minus 1 into D, like that. You can, from the term also you can find out A4 is equal to A plus 4 minus 1 into D. So here that is A plus 3D we get. How many times? 2. To find out the fourth term, how many times we have to add the D to the first term? 3 times. Like this you can easily find out. A4 means A plus 4 minus 1 into D, that is A4 equal to A plus 3D. Then AN. So how will you find the nth term? That is A plus N minus 1 into D. For fourth term you have subtracted 1 from 4. Like that, for nth term you have to subtract 1 from N. It becomes A plus N minus 1 into D. So by using this formula you can easily find out any term of that AP. So how will you find out a common difference? Common difference means A2 minus A1, succeeding, any succeeding minus preceding, or you can take A3 minus A2, A3 minus A2, or A4 minus A3. Okay, as I did in the previous examples. So like this you can easily solve or easily find out the common difference of an AP. Okay, the first exercise is on the basis of this general form only. Next we will move to the nth term of an AP, that is AN equal to A plus N minus 1 into D. As we have already discussed this one, here A is the first term and D is the common difference, N is the number of terms which are present in that AP, and AN is the nth term. It is also said to be last term. The term is denoted by small l. Last term is also said to be last term. So by using this formula, you can find out any term of the AP, any term in that AP. To solve the first exercise, and that the first question: in which of the following situations does the list of number involved make an arithmetic progression, and why they are asking? Okay, so they are given some situations which come across in our day-to-day life. Okay, so whether the list of number which are obtained by these situations, that they formed AP or not, that we have to find here, and we have to give the reason. Okay, see that the first one, the taxi fare after each kilometer when the fare is rupees 15. So for first kilometer it is 15. Okay, then for each the first kilometer is rupees 15, and then for the next every kilometer he will take, the taxi driver will take rupees 8. So then it forms like this. Here the first kilometer 15 rupees we have to pay. If we go another kilometer, then we have to pay 15 plus 8. If we move another kilometer, then we have to pay 15 plus 2 times we have to pay that 8 rupees with that 15 rupees. Like this it is going on. Okay. So then the amount will be for first kilometer 15 rupees, for second kilometer 23, for third kilometer 21, and then for the next kilometer it is 39. So like this the fare is going on. Okay. So here the D will be 23 minus 15 is equal to 31 minus 23 is same, that is 8 rupees. Okay, so where the common difference is same, therefore it forms an 80, like this here. Then we will move to the next one, that is second one. The amount of air present in a cylinder when a vacuum pump removed the air remaining in the cylinder, 1/4 of the air remaining in the cylinder at every time. Means every time how much air is present in the cylinder, it's 1/4 we are going to remove. Not every time we are not going to remove the 1/4. How much air is present in the cylinder, that's 1/4 we are going to remove. So that's why the solution is go like this. Consider the air present in the cylinder be one volume or one V. Okay, V of air. So first we have to take 1/4 of that 1V. Okay, then A is equal to, then the first term becomes 1V. Then every time if we remove 1/4 of the air, if we remove 1/4 of the air present in the cylinder, then it becomes, then the second time if we remove 1/4 of the air from 1V, see what we get? A2 is equal to, then second time the air remains in the cylinder will be V minus 1/4 of V. That V means 1V. Okay, so it will be, one is fraction, another one is natural number, so we should take it LCM. So LCM becomes 4. Then here nothing means 1. We will simplify this one here. Here 1V it is actually 1V. So V means 1V. So denominator is always 1. 4 ones are 4 will be the LCM. So this 4 will multiply in the numerator. 4 ones are 4V becomes, and this one will multiply with this numerator. So 1 ones are 1V we get. Then the next one is 4 minus 1, what we get? 3/4 of V. So first what we have, here we have the first term is 1V is the air present in the cylinder. After removing of 1/4 of V, what we get? 3/4 of V is the air remaining in the cylinder. Okay. Now see, next we have to remove the 1/4 of this A2. 1/4 of this A2. See here, A3 is equal to A2 minus 1/4 of A2. Why we are taking A2 once again? Because not only we are subtracting 1/4, because here we have to remove 1/4 of the air present in the cylinder every time. Okay, now it is not full. Okay, the air is the cylinder is not full with the air. So already we have removed 1/4 of the air of that cylinder. Now how much is the air present in the cylinder? That is A2. That is 3/4 times. Okay, so in that 3/4 times we have to remove 1/4 of the air. So if we remove 1/4 of the A2, so it becomes 3/4V minus 1/4 of 3/4V. So 3/4V minus 1 3 is 3, 4 4 is 16V. We get 3/16V. That is 1/4 of 3/4. So now same, the denominator here is 4, there is 16. You can take 16 fours also, or you can take as 16 is the multiple of 4, 16 as a LCM, then 4 fours are multiply 4 to the numerator, you get 12V. As here 16 is the denominator, so there is no change in the numerator, it becomes a 3V as it is. So 12V minus 3V, we get 9v divided by 16. So if 9 and 16 will convert it as a exponent form, it will form 3 by 4 whole square v. So here 3 by 4 to the power 1v, 3 by 4 to the power 2v. The next number will be 3 by 4 to the power 3, like this. If exponent of the term in the progression is increases with respect to the number of terms, then it is not in the form of AP. Then it will not form an AP. Now we'll move to the next concept. Next problem, that is fourth one. It is related to compound interest. The amount of money in the account every year and 10,000 is deposited at compound interest at 10% per annum. Okay, so we should use that compound interest formula and put the values here. 10,000 is the principal amount, 8 is the rate of interest. So those two are very important. So in the first year, the compound interest is like this: 10,000 into bracket 1 plus 8 by 100 to the power 1. In the second year, that is A2, 10,000 into bracket 1 plus 8 by 100 to the power 2. In the third year, the compound interest is 10,000 into bracket 1 plus 8 divided by 100 to the power 3. So here also, as we see in the previous example or in the previous question, here also the power is going on increases, or the exponent is going on increases. If the power of the sequence is increases with respect to the number of terms, then it should not forms an AP. Okay, so this statement also you can use for that second one. Okay children, so like this we will solve the first. Okay, if you get any difficulty you can ask me, then further we'll discuss in the next video. Thank you for watching. Please subscribe, share and like it. Thank you.